All right, this is a lesson on finding slopes given 2 points on the line. And basically, the directions will usually say something like this. It'll say, find the slope of the line containing the two given points. So in our example, here are my two given points. So the first point is -6, 4, and that other point is 3, 7. Now, if I just want to find the slope of that line, we have a slope formula. So the slope formula, remember, is y2 minus y1 divided by x2 minus x1. And remember, when we talked about the slope formula before, if you start with y2 in the numerator, then you must start with x2 in the denominator. The order does matter in the denominator. So y2, x2, y1, x1. So notice the subscripts correspond. Okay. Now, before we actually continue, let's remind ourselves how we derived this slope formula. So here's how the slope formula came about. Just to remind you or to inform you. So if I were to draw a line going through this plane, so here's the x-axis, here's the y-axis, and remember a line, two distinct points define a line. So let's say these are my two distinct points. And if I want to find the slope of this line, all I need are 2 points. So let's say it's these 2 points. So notice that there are no numbers on this number line, and there's a reason for that. So I did not put any numbers because I didn't want you to look at these in terms of numbers like the order pair 3, 5 or something like that. So this is going to be in general. Okay. So if I call this my first point, then remember our first point, then this is the x coordinate of my first point. So notice x sub 1, a subscript 1, comma, and then this is the y coordinate of my first point. So y sub 1. Here, this is the x coordinate of my second point. So x sub 2. And then the y coordinate of my second point, y sub 2. All right. Now, from here, though, I can label this x-axis and the y-axis. So here's the origin. So notice that to get to this point, I'm going to go this many units to the right and then go up, right? So notice, though, that this number here must correspond to what you see here. So this right here is going to be noted as x1. So that and that must correspond. In the same situation, when I go up, that's your y1. So this right here should correspond to your y coordinate. So that's y1 right here. All right. So x1, y1. Over here, if I go from the origin and go to this point, that's going to be right here. It's not. I'm just trying to make sure it's scaled as best I can. So this will be x2, right? And then up here, that's going to be on the y-axis. That's going to be y2. So notice what these came about right here. So start the origin. This is x1, corresponds to this. See that x1? And then y1 right here. And then this will be x2 and then y2. I didn't draw it very well, but y2, somewhere around here. Okay? All right, now I am then going to draw a triangle. I'm going to go from this point to that point. Remember the idea of rise over run? So I'm going to run to the right and then rise up. Okay? Run, rise. Rise over run. Remember the slope? Rise over run. We're going to talk about that in a little while. Okay, now what I have to do before I can continue talking about where this came from right here, I've got to locate the coordinates of this point. See where this right triangle is formed right here? I've got to locate the coordinates of that point. Well, that's easy because you started the origin. So you're going to go to the right x2. So that's x2 for the x coordinate. And you're going to go up y1. So this point has coordinates x2, y1. All right, now here's the rise. And we're going up and down as you rise. And then this is the run. Okay? So the slope, remember, is rise over run. So now let's look at the rise. So remember, if I'm going to find this vertical distance right here, I'm going to subtract the y coordinates. So I'm trying to find this vertical distance. This vertical distance corresponds to this vertical distance. See that right here? So let me show you. So this right here, this vertical distance corresponds to this vertical distance. So they're the same length. So this vertical distance, the length here will be y2 minus y1. Same thing here, y2 minus y1. So this is y2 minus y1. The run, So this distance right here, this distance going from here to here is the same as this distance. Okay, and so if I want to find this distance, I'll say x2 minus x1. So it'll be x2 minus x1. And so now you have your rise, you have your run, and so rise is y2 minus y1, and the run would be x2 minus x1. And so that's where the formula comes from, is that idea that you see here. So notice the slope formula, y2 minus y1 over x2 minus x1. Okay? All right, so now let's look at number 1. Now, when finding the slopes, some students find it very helpful, since there are several notations here, y2, y1, x2, x1, they find it very helpful to label those coordinates. So for example, if you want to let this be x1, you can't, if you want this to be your first point, then you'll call this x1, y1. If you want this to be your second point, then you'll say x2, y2, okay? And then let's use the formula. So the slope is y2 minus y1. Now remember, the order matters, so be careful. So if you put y2 first, then you got to put x2 first in the denominator. So 7, subtract, remember that's a subtraction, and then you can subtract y1. Well, y1 is 4, divided by, and then since I started at y2, I'm going to start with x2. So x2 is 3, subtract x1, which is a negative 6. Okay, now, the numerator is easy. 7 subtract 4 is 3, right? The denominator, now be careful, the denominator, 3 subtract negative 6 means 3. Remember, you can always change subtraction to addition by adding the opposite. So that's 3 plus the opposite of negative 6, which is 6. So that becomes 3 divided by 6. 3 plus 6 is 9, which reduced, you're expected to reduce, which is 1/3. So make sure you reduce, okay? Make sure you reduce. All right, so the slope is 1/3. That's what you found the slope to be. All right. Now, remember, it did not matter whether you call this a first point or this a second point, right? So notice we got the slope to be 1/3, and that's all they wanted. You're done. That's the answer. So the answer, you'll say slope is 1/3. All right. Now, notice what I was saying is it did not matter whether this was your first point or this was your second point. It did not matter. So I just want you to show you. So notice if you go ahead and let this be the second point, then x2, y2, and this be the first, x1, y1, you'll still get the same answer. So watch. The slope equals, let's see, y2, which is 4, subtract y1, which is 7, right? Divided by, now since I started with y2, I'm going to start with x2. Negative 6, subtract x1, which is 3. Well, 4 subtract 7, now be careful, 4 subtract 7 means 4 plus a negative 7, right? So we can always change subtraction to addition by adding the opposite. So 4 plus the opposite of 7 is negative 7. Same thing here, negative 6 plus the opposite of 3, which is negative 3. So 4 plus a negative 7 is a negative 3, and negative 6 plus a negative 3 is a negative 9. And remember, negative divided by negative is a positive, and then reduce, you get 1/3. So it did not matter. It did not matter which approach you took. Okay? All right, so that was the slope. That's the slope. So the slope of that line that contains those 2 points is 1/3. Now what I want to do is I want to show you, remind you what the graph looked like. All right, so you're basically done. You just use the slope formula, you're done. But here's the graph, just to remind you. So we had the point negative 6, 4. So here are points negative 6, 4, and the other point was 3, 7, right? So if I go ahead and plot those 2 points, so here is negative 6, 4 right here, all right? And then 3, 7 is right here, okay? And then I'm going to go ahead and draw the line. And when I draw the line, I'm going to get, let me find the ruler. All right, so I'm going to get this line. I'm going to go ahead and draw that line right here. So here's the line. And remember the slope, we got the slope to be 1/3, remember? Slope was 1/3, so that's positive. So if you were to graph that line, notice that since the slope is positive, your line rises, right? Okay, but here's what I wanted to remind you. So remember when we did rise over run? So if I start at, let's say, at this point, it does not matter whether I start here or here, but if I start here and we go to that point, I'm going to go to the right like this. So here's my run, and then I'm going to go straight up from there. See that? So my this is my directions. I went here. So my run is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And my rise is 1, 2, 3. So my slope would be rise over run, which is my rise is 3 and my run is, remember we went up, right? And my run is 9. But I got to reduce, so I get 1/3. So I just wanted to remind you about that, about the idea of rise over run in terms of going from one point to another. Okay? All right. Okay. And oh, and then let me just show you this. So remember I started here, right? So if you wanted to, and there's all kinds of directions you can go. So just to remind you about some things. So if I look at that point, that line again, so here's -6, 4 right here, and then 3, 7 is right here. And again, let's draw the line, something like this. There's all kinds of directions you can go, but the slope's going to end up being the same because the line is the same. So this line, regardless of whether you go here to here or here to here, the slope's always going to be the same because of that line. The line is the same line. All right, so if I, let's say, start here and go this way, let's say, so I'm going to go to the left like this, all right? So I'm going to the left, notice the arrow, and then we're going down, right? Notice the arrow. All right, so let's talk about how many units we went to the left. So I went 1, 2, 3, 4, 5. Oops, let me start again. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I went to the left, so I'm going to call that a -9. 9 because I went to the left. And I'm going down 1, 2, 3, so that's a -3. So the slope, remember, is rise over run. So my rise is a -3. And my run is a -9. And remember, -3 divided by -9 is a positive 1/3. All right, so it does not matter. Remember, it does not matter which direction you go. You'll still get, if you're doing it correctly, you'll still get the same slope. All right, but in number 1, all you need to do is use the slope formula and notice how quick the answer is. You got 1/3. All right. Okay, let's look at number 2. So number 2, we have this. Okay, so number 2, we have the 2 points, -4, 7, and the other point is 5, -3. And you want to find the slope. So the quickest way is to use the slope formula, which is y2 minus y1 over x2 minus x1. And again, it helps if you label those points. So let's call this the first point, this is the second point. So if this is my first point, this is going to be the x coordinate of my first point, and then this is the y coordinate of my first point. So x sub 1, y sub 1. This is the second point. We'll call this x sub 2, y sub 2. And then it's just a matter of you substituting. So that's going to equal y2, which is -3, subtract y1, which is 7, divided by x2, which is 5, subtract x1, which is a -4. All right? Now, you have all kinds of signed numbers here, so be careful. So -3 subtract 7 means -3 plus the opposite of 7, which is -7, divided by 5 subtract -4 means 5. Remember, always change subtraction to addition by adding the opposite. So that's 5 plus the opposite of -4, which is 4. A -3 and a -7 is a -10, and 5 plus 4 is 9. So the slope is -10/9, and that's it. That's the slope. You found the slope. So the slope equals -10/9. All right, and you cannot reduce this. But real quick, let me just show you on the graph what that looks like. So if you plot the 2 points, again, this is number 2. If you plot the 2 points, -4, 7, and 5, -3, let's see what we have. So here is -4, 7 right here. And then here is 5, -3, start at the origin, 5, -3 right here, right? Okay, and then we draw the line. And let's see what we get. So when I draw the line looks like this. And here's the line with the arrows. And remember, the slope was negative, right? So that means that the line better fall, and it is. All right, and so let's just start with, let's say, this point, and let's go to that point here. So I'm going to start here. So I'm going to go, now watch what's happening. So I'm going to go down like this. See how I'm doing it? So we do it this way. So down like this. And let's draw a right triangle, kind of like this. All right, so go from this point to that point. I'm going down, and I'm going to the right. See this? Down and then right. So when I go down, let's count the units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll be a negative 10 because I went down, right? And then and notice that negative 10 corresponds to this negative 10. You see that? And then when you go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a positive 9 because I'm going to the right. So the slope is rise over run. So remember, rise is up and down, run's left and right. So that's negative 10 divided by 9, which is what you got here. Okay, so very simple, right? Very simple process. So that was number 2. Let's look at number 3. All right, so number 3, we have the point -6, -5, and then 4, -3. So let's go ahead and find the slopes. Remember, the slope formula is y2 minus y1 over x2 minus x1. And then it helps to label the points. So let's call this x1, y1, and this will be x2, y2. And again, it does not matter whether this is x1, y1, or this is x2, y2. It does not matter. You'll still get the same slope. So y2 is a -3, so make sure you put the correct values in those spots, though. Minus, so you're subtracting y1, which is -5, divided by x2, which is 4, subtract x1, which is -6. All right, so you have quite a few signed numbers here. So that's going to equal, remember, change all these subtraction to addition. So we -3 plus the opposite of -5. So -3 plus, and then the opposite of -5 is a +5, divided by 4 plus the opposite of -6, which is a +6. So -3 plus 5 is 2, right? And then 4 plus 6 is 10, and then reduce, that's going to be 1/5. So the slope is 1/5. That's your slope. If you were to look at this in terms of a graph, let's see what we get. So in terms of a graph, so remember the slope is 1/5, right? So in terms of a graph, this number 3, we have -6, -5, and the other point is 4, -3. So if I plot those points, -6, -5, so go to the left -6 and then down 5, right here. So go to the left 6 and down 5. There's that point -6, -5. 4, -3, I go to the right 4 and down 3, right here. And draw the line like this. All right. And then notice the line is rising, which it should be because the slope is positive. All right, now let's go ahead and go from one point to another. So let's find the slope using rise over run. Slope, remember, is rise over run. All right, let's start here. It doesn't matter where you start. Let's start here and let's go this way. So I'm going to go down like this and then to the left, right? Down and to the left. Okay, so I'm going down and then to the left. All right, so when I go down, I went 1, 2 units, so that'll be a -2. And then when I go to the left, that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's -10. And notice those numbers, these numbers here, you'll see right here. Except this is +2 over +10. This is -2 over -10. But remember, a negative divided by negative is a positive, right? All right, so it's still 2/10. See that? 2/10, 2/10. But reduced, you get 1/5. Right? So it did not matter. It did not matter whether you went like this or whether you went like this or whether you started here or there. It does not matter. You'll still get the same slope of 1/5. All right, so that's number 3. Let's look at another one. This will be number 4. All right, number 4, we have the point -5, -2, and the point 6, -8. So using a slope formula, slope is y2 minus y1 over x2 minus x1. So remember, order matters. Notice the subscripts align. y2, x2, y1, x1. The order must matter. The order does matter, so you must make sure you're writing this correctly. Let's go ahead and label these. It does not matter whether this is a first or second point. I'm just going to call it the first point. So it'll be x sub 1, y sub 1, and this will be x sub 2, y sub 2. And it's just a matter of you taking those values, putting it back into the formula. So y2 corresponds to negative 8, subtract y1, which is a negative 2, divided by x2, which is 6, subtract x1, which is negative 5. All right, so rewriting this better, I get, remember subtraction, always change subtraction to addition. So it becomes negative 8 plus the opposite of negative 2, so it's negative 8 plus 2, divided by, and then 6 subtract, so plus the opposite of negative 5, 6 plus 5. So negative 8 plus 2 is a negative 6, and then 6 plus 5 is 11. So you get the slope being negative 6 elevenths. All right. That's your slope, okay? And if you were to go ahead and let's say you wanted to plot those points, this is number 4. If you want to plot those points, you would have negative 5, negative 2 right here. And then the other one is 6, negative 8. So negative 5, negative 2, I go to left 5, down 2. And then 6, go to the right 6, and then down negative 8 right here. And then let's go ahead and draw the line. And you get this line. Notice the line's falling, right? So the slope better be negative, and it better be negative because my slope is negative, right? Okay, now let's go ahead and use rise over run just to show you. You learned that in previous lesson. Slope is rise over run. So if I start here, and then let's go this side. Oh, sorry. You can start here and go this side, or start here going that side. Does not matter. Or you can, again, you can do this one going this side, or this one going that side. Does not matter. I'm going to go ahead and go this way. So starting here, I'm going to go this way until I get a right triangle like this. All right, so there's my right triangle. All right, so I'm going to the right, and I'm going down. So let's talk about the right. So how many units did I go to the right? I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then how many units did I go down? 1, 2, 3, 4, 5, 6, right? So that'll be a negative 6, so I went down. So my rise is negative 6, and my run is positive 11. So negative 6 over 11, and that's what you saw. See that? All right, and then here's number 5. So number 5, the last one, we have negative 8, negative 5, and negative 4, 7. So again, just like we did number 4, the slope formula is y2 minus y1 over x2 minus x1. And so let's go ahead and label these x1, y1, x2, y2. So your y2 is going to corresponds to 7, right? So you're going to say 7, subtract y1, which is negative 5, divided by x2. You must start with x2. So since I started with 7 in the numerator, I've got to start with negative 4 in the denominator. So negative 4 subtract x1, which is negative 8. So changing these subtractions to addition, I get 7 plus the opposite of negative 5. So it's 7 plus 5. The opposite of negative 5 is 5. And then negative 4 subtract negative 8 means negative 4 plus the opposite of negative 8, which is a positive 8. 7 plus 5 is 12. And then negative 4 plus 8 is 4. And then 12 divided by 4 is 3, right? So you get 3. So the slope is 3. And if you wanted to, so the slope of that line is 3. So if you wanted to look at the graph, just to remind you, just like we did in the previous problems. So if you look at this in terms of the graph, let's see what we get. So let's go ahead and plot those 2 points. So this number 5, my 2 points are negative 8, negative 5, and the other one is negative 4, 7. So negative 8, negative 5 is, let's go bring that up. So negative 8, negative 5 is right here, right? And then negative 4, 7. So negative 4, 7 is right here. And then drawing the line, when I draw the line, I get this right here. I get this line, right? And then remember the slope is positive 3, right? So the slope is positive, so notice the line is rising. It better rise. All right, so let's go ahead and do rise over run. So slope is rise over run. Let's start with this one, and then let's go this way. So I'm going this way, like this, and then going down, and let's just make sure we draw a right triangle. All right, so there's my right triangle. All right, so starting here, I went to the right, correct? So I went to the right 1, 2, 3, 4. So that's a 4. Since I went to the right, it's positive 4. And then I'm going up. So it'll be positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my rise, there's my run. So my rise is 12, my run is 4. Notice that corresponds to what you saw here. See that? 12 fourths, which is 3, right? And so that's it. That is the lesson on finding slopes given 2 points on a line. So basically, we use a slope formula. And remember, the order does matter, but it does not matter whether you let this be the first point or this be the second point. All right, so that's the end of this lesson.